This lecture will wrap up our discussion of the Introduction to the Science of Psychology. We have already covered the scientific method and 3 types of research. This lecture will build on those topics and extend our understanding of the processes involved in conducting good and ethical research. This lecture will discuss some important aspects of the data we collect in our research. These include validity, reliability, and accuracy. I will then introduce you to some aspects of data analysis. This will be a very brief overview. A much more detailed discussion of data analysis will be covered in Psychology 302, Statistical Methods in Psychology. We will then end with a short discussion of ethical concerns in doing research. When collecting data, we need to make sure that we are using the correct scale or instrument to measure the dependent variable. One consideration about that instrument used to measure your dependent variable is its reliability. What is reliability? Well, think about the common usage of this term. If I say my car is reliable, what do I mean? Well, it means dependable or stable. It may not be flashy, but it starts when it should. I know what to expect. Reliable data is similar in that it is stable. It doesn't fluctuate wildly from measurement to measurement. So let's use a concrete example to illustrate this point. Imagine you're a researcher with the hypothesis that younger adults channel surf more often than older adults. A reliable measure would show that TV viewers are stable in the amount of time they spend on each station. For example, a quick changer should be consistently quick to change channel when measured this week versus next week or the week after. An unreliable measure would bounce around much more often. Internal validity is vitally important to doing research. At its most basic, internal validity is our ability to make statements about cause and effect. Recall from the lecture on experiments, there are a number of ways to increase our ability to make causal statements, and others that can decrease it. In order to state that the independent variable frustration causes the dependent variable aggression, we need to ensure that there are no other factors that vary between the groups. That is, there are no confounds. One way to do this is through experimental control, ensuring that the experimental condition and control condition are identical in all ways except the independent variable. Recall that people are different in many different ways, be it mood, patience, outgoingness, prior exposure to violent media, maturity, and many other individual differences. Do you recall how we control those differences? One way is through random assignment. Imagine the 6 people on the top left of this graphic are the people who volunteered to take part in our study. We need to create 2 groups. One way to do so would be to take the first 3 to volunteer and put them in one group, and the next 3 in the other group. Why might this be a problem? Well, the people who first volunteered may be different than the 3 who joined later. It could be on a dimension such as procrastination or extroversion. Whatever it was, you have potentially created a confound in your study. A better way to create the group is through random assignment, with each person having the same chance to be in one group or the other. Here's another example. Imagine I want to evaluate a new psychology textbook against the old one. My independent variable is the textbook, and the dependent variable could be final grade. Imagine I teach 2 introductory psychology classes, one on Monday and Wednesdays from 8 to 10 in the morning, and the other Tuesday, Thursdays at 4 to 6 in the evening. I decide to use the new textbook with the Monday-Wednesday class, and the old one with the Tuesday-Thursday class. At the end of the term, I find that the Monday-Wednesday class performs significantly better. Could I say the difference in grades was caused by the textbook? No. It could be that individual differences were present in the students who took the morning versus the evening class. That is, the students more interested or already more proficient in psychology took the morning classes, or some other variable. This could be solved by randomly assigning students to either the morning or evening class. Would this totally solve the problem? Likely not. It would deal with the individual differences, but there are still other confounds. It could be that learning psychology is easier in the early morning with a fresh mind. It could also be that I'm a morning person and do a better job lecturing in the morning. It could be the classroom environment is different in the afternoon and morning. Therefore, to maximize control, I would need to ensure that the two classes were identical to each other as possible, with the only difference being the textbook. Another important consideration for validity is what you are actually using to measure the dependent variable. That is the instrument that you're using actually measuring what you want it to? This example shows the research hypothesis again that younger adults channel surf more than older adults. The most valid measure of this would be minutes per channel. If instead you measured all the time watching TV, you're not actually measuring the dependent variable you're interested in. That is, it's not a valid measure of your dependent variable. As you can see, using the incorrect measure would result in a finding that is opposite that found using a valid measure. In order for the measure to be valid, it also has to be reliable. What does this mean? Well, imagine a bathroom scale that you stepped on this morning and it says that you're 110 pounds. You step on it tomorrow and it says 390 pounds. The next day, 42 pounds. That scale is unreliable. Do you think it is actually measuring your weight? Probably not. So it's also not valid. The final consideration about what you use to collect your data is its accuracy. Accuracy is the degree to which our data is free from error. There are many ways that error can influence a measure. It could be random error, which is error that fluctuates each time you collect it. The previous example of the scale is a good example of random error. It gave you a different measurement each time. Sometimes it added random weight, sometimes it subtracted random weight. It could also be systematic error, which is error that remains stable. For example, a scale that incorrectly set so that it adds 4 pounds to each measurement. Which are you more likely to notice? A scale that bounces around or one that adds a set amount? Likely the bouncing scale, which is why systematic error is often most problematic. However, if you detect systematic error, it's easier to correct than random error. Here's another example of these two types of error using the channel surfing example. As you can see, the individual measures with random error bounce around. However, if this error is truly random, over time, the average of the measures should be close to the actual underlying time. The systematic error example shows that 2 seconds of error is occurring on each measurement. Systematic error, as you can see, is a bit more problematic in that over time it doesn't correct. It remains 2 seconds high, which results in the average also being 2 seconds high. This would have an impact on the data analysis, which is our next topic. Statistics are important because it allows us to detect effects and to evaluate whether those effects are likely due to chance or not. Differences between two groups in an experimental study could be due to the simple chance differences in who is in each group. Statistics allow us to determine how likely that chance is. Typically, if the likelihood that an effect was due to chance is below 5%, we call that statistical significance. Another benefit of statistics is it allows us to present complex sets of data in a way that is intuitive and quickly understandable. Often this is in graphical form, like this bar graph. However, it is also possible to present this data in a dishonest or leading way. Imagine you're examining advertisements for trucks, and you come across an ad with the following graph of the percentage of various brands of trucks that are still on the road after 10 years. You might say, wow, that brand of truck is way more reliable than the others. In fact, it looks to be twice as reliable as brand Y. And boy, brand Z looks like a total piece of junk. Now look a bit closer at the graph. Do you see what's going on? The data is correct, but the graph is not telling you the whole story. Here's a more honest chart, showing you the full range of possibilities for the dependent variable of percentage of trucks on the road by brand. The difference from the first graph sure doesn't look that impressive anymore. In fact, the difference between our brand and the terrible junker brand Z is less than 3%. Now, all things being equal, picking the more reliable brand would be a good plan. However, maybe there are other differences that are more important to you than that 3% increase in reliability, like gas mileage, or price, or carrying capacity, or the number of cup holders. While honestly reported data can't lie, how it is presented can tell different stories. For this reason, understanding statistics is an important skill for anyone to learn, not just researchers. There are two general types of statistics we will discuss: descriptive and inferential. Descriptive statistics summarize the full range of the data collected. In fact, for each variable, two numbers typically tell most of the story: one that describes the central tendency and one that describes the variability. Central tendency is a measure that describes the typical response on the variable. There are three ways to do this. First, and most common, is the mean, which is the mathematical average of all of the observations. This should be familiar to you. It is calculated by adding up all the scores and dividing by the number of observations. For example, if we had 3 observations with the score of 1, 2, 3, the total would be 6. Dividing that number by the observations, or 3, the mean is 2. The median is simply the middle number. This is obtained by lining the numbers up in ascending order from lowest to highest and selecting the number in the middle. For example, using this set of 7 numbers, we would line them up in ascending order and then select the middle number, 6. The mode is the most frequent occurring score. If I had the following numbers, what would the mode be? Often, data is presented in a frequency table, like this, which shows the scores, labeled as X's, and the number of times each appears. Here is a frequency distribution of our data. As you can see, the score 4 in the X column occurred 5 times, as seen in the frequency column. That is the most commonly occurring number, and it is the mode. In addition to central tendency, the other important descriptive measure is variability, which is the degree to which the scores on the variable fluctuate around the mean. One measure of variability is the range, which is the difference between the lowest and highest score. Using this set of data from a previous example, you can see that the lowest score is 3, and the highest is an 8. There are a couple of ways to calculate the range. The most common way to do so is to take the highest score and simply subtract the lowest score. In our example, 8 minus 3 equals a range of 5. In statistics, the range is not used very often as a measure of variability. Rather, the most commonly used is the standard deviation. You'll learn much more about the standard deviation, including how it is calculated and how it is used in 302. For our purposes, it's enough to understand that it is a measure of how much scores vary around the mean. It is the typical variation from the average of the scores. Here you can see 2 distributions of scores with the same mean. However, the blue distribution varies a lot, as demonstrated by how flat and wide it is. The red distribution varies substantially less. Therefore, the blue distribution has a larger standard deviation than the red distribution. Through your time as a psychology student, you will see distributions that look like this very often. These bell-shaped distributions are known as normal distributions, or normal curves, also Gaussian distributions. This distribution of scores is interesting in a number of ways. First, the distribution is symmetrical, with scores following equally on the right and on the left of the mean. Also, the mean, median, and mode are all located in the same place, dead center in the distribution. This distribution is also found very frequently in the real world. For example, think of extroversion. Most people tend to be average on extroversion. That is, sometimes they're outgoing and sometimes they're introverted. People extremely high or low on extroversion tend to be rare, with more extreme examples becoming less and less likely as we go outwards. My favorite example of a normal curve found in the real world was an architectural study on one of the oldest monasteries in Europe. Important to our discussion, it had a dining hall right next to the main worship area. There was a stone doorway about 6 feet wide with a stone floor between these two rooms. When researchers examined the floor under the doorway for wear, what do you think they found? Well, think about where you normally walk when you go through a door. In the middle. There might be some variation in people, with some going a bit to the left and some going a bit to the right. But the further you go towards the sides, the less traffic that part of the floor gets. That is what the researchers found, a nearly perfect inverted normal distribution. At least 6 times a day, for over 1,000 years, dozens of monks had made the trip through that doorway, slowly eroding away the stone, mostly in the middle, with further from the middle becoming less and less eroded, with the edges near where the floor met the wall having very little wear at all. While normal distributions are common, they're not the only type of distribution. One other common type is a skewed distribution, with extreme scores being more likely on one side of the mean than the other. Here's an example of a positive skewed distribution: average household income. As you can see, the median or middle score is right around $30,000. That is, 50% of people make less than $30,000 and 50% make more than $30,000. However, the mean is at $70,000. Why is there such a difference between these two measures of central tendency? Well, think about how income works. What is the most extreme income on the left side of this distribution? Well, it's 0. The least amount of income you can have is no income. What is the maximum score to the right of the distribution? Well, it could be in the billions of dollars. So the fact that higher scores are more likely, and in fact occur more often than low extreme scores, results in the mean being pulled higher than the median. What this means is that you can use a different central tendency to tell a different story. If you're a lobbyist who is trying to argue that people in the US were doing great financially, which central tendency would you use? Well, likely the mean, since it paints a rosier picture to say that the average family is making $70,000 a year. But is the average family actually making that amount? If you want to point out that the average family isn't doing great, you could point to the median and say 50% of families in the US are making under $30,000 a year. So descriptive statistics tell us a story about the patterns in our data. That is, they describe the center and the spread of the distributions. However, we want to do much more than merely describe. We want to explain. Inferential statistics allow us to determine whether the differences or effects that we find actually exist, and the likelihood that those differences or effects are meaningful. There are many types of inferential statistics, and you'll cover a fair number of them in 302. Psychologists engage in many different research activities, usually involving human participants. There are a number of safeguards to protect these research participants. Recall that the American Psychological Association, or the APA, is the largest scientific and professional organization representing psychologists. The APA has published codes of ethics to guide both clinicians and researchers. The foundation of this code is to be respectful of participants and to treat them with dignity and protect them from possible harm. The ethics of research are sometimes gray, and often what is deemed acceptable changes. Because of this, another protection for participants in research is the Institutional Review Board, which is a committee of people that usually includes researchers and community members who review proposed research plans and evaluate the scientific merits and possible harms to participants. IRBs in the United States are federally governed. IRBs are generally found in research universities and other larger organizations that engage in federally funded research. If the IRB finds the research overly risky, the researchers can adjust their design to make it less so. However, if they are unable or unwilling to do so, the research cannot be conducted. There are 4 major ethical concerns for researchers. These are privacy, access to data, informed consent, and relative risks. Privacy of participants needs to be protected. However, some research can be observed and recorded without any impact to the participant. For example, if I wanted to study flirting, I could sit in a bar and make note of flirting behavior without identifying in my records any individuating information, like the name of the people. However, some behaviors are expected to be private. Imagine the following. You're a freshman student just moving into the dorms for the first time. You meet your roommate who will be living with you for the year. You expect that initial conversation to be private, right? Well, in the 1930s, researchers hid under the beds in dorms and recorded these initial conversations. This study was conducted prior to many of the ethical concerns and rules that have been enacted since. Other behaviors, cognitions, or feelings might be distressing or very personal. In those cases, we want to ensure that the privacy of participants is protected and their individual results are kept private. Speaking of that data, it is important to keep data confidential, not sharing data that is identifiable. That is, it can be tied to a specific person. As researchers, when we report on data, it is aggregated or average results, not specific individual results. For example, I would report that when children in the study were frustrated, they acted more aggressively, not that Billy, Ramon, Malik, Alexis, and Sally were more aggressive. Does that mean that participants in a study are anonymous? Not necessarily. While confidentiality means that only the researchers know which participants reported what, anonymity means that even the researchers don't know who said what. All research results are confidential, but not all are anonymous. Informed consent is also important in psychological research. This means that people who are participants in studies know what the risks and benefits of doing so are. If the questions we are going to ask could be potentially upsetting, we need to let people know this before the study starts. We also need to let them know that they are free to withdraw from the study at any point. Sometimes we can't fully reveal the purpose and design of the study. For example, if we want to find the effect of frustration on aggression, we can't tell people what we're doing because it might bias the results. However, in the informed consent, we could say that it is possible they might become upset during the process. Regardless of whether the informed consent fully outlines the study or not, at the end of the study, participants need to be fully debriefed, during which the full design and purpose of the study is explained. It is also important at this point to ensure that participants are leaving in relatively the same psychological and emotional state that they came in. So if you cause aggression due to your manipulation of frustration, you would need to explain what you did and why, and also make sure they're not still angry when they leave. Some studies come laden with some degree of risk to the participant. For example, in the frustration-causing aggression study, a child could smash a toy car too hard together and injure themselves. This possibility of harm needs to be weighed against the benefits of doing the study. This is a job for the researcher to do early in planning the study, perhaps making changes to minimize the harm further. It is also a job of the IRB to determine if the risks outweigh the benefits. Doing psychological research is a complex but very rewarding endeavor. By carefully designing studies and using inferential statistics, we have learned many interesting and valuable things about human behaviors, thoughts, and emotions. These findings have informed theory, which have resulted in further hypothesis and testing. This river of research is ever flowing, filling our seas of knowledge. Hopefully this and the other lectures on methodology will help you to start to navigate this river, and perhaps make additional contributions to the field. Now that you've learned the basics of psychological science and research methodology, you're much better prepared to start learning about the different areas in psychology, including developmental psychology, social psychology, clinical psychology.